So welcome everyone to our CCNA 3 class. I just got this email today, so you can see here the networking support CCST networking went live today. I thought it was going to go live tomorrow, but it went live today. You'll notice that there is as far as the alignment right now, it is actually inside of Skills for All. It's the networking basics, network device initial configuration, addressing basic troubleshooting, and support. Those four in Skills for All maps to CCST networking. I have a real strong feeling that if anybody completed CCNA 1, they could also very easily pass this exam, but I'll look at it on Wednesday and have a little more to say about that. You notice it says it goes live end of the day on April 26th, but I actually just looked and it looks like you can schedule it. So, although it said it was not going to go live until the 26th, it looks like you can schedule it right now. So that's interesting. Maybe you can't schedule it till the 26th, but just be aware that it looks like it's already live. I think this is going to be a really good certification, especially for anybody teaching at a high school level, and even you in community college level. I think it's going to be one that we can use as our like a beginning cert after CCNA 1 to get folks something, so that they're able to feel like they're able to get in there and take care of that. Likewise, we're going to have the CCST security, which I think is a pretty easy certification to get. Any questions about that? Because that's exciting news.
I have a question.
Sure, John.
In our state, they're mapping all of the courses to certifications, and Network Plus is on the list, but I don't know if the CCST is going to be on that. And some committees have refused to allow people who have only CCNA 1 in their program. They're requiring them to take Network Plus, which is, I think, is maybe covers more, but it's very shallow. You can't do anything with this Network Plus.
Right.
I mean, technically, and I'm concerned that I'm going to argue that again the next time we meet that committee, cybersecurity. But they had CCNA security in there, but now, when it disappeared a couple of years ago, do you think they're going to bring that back?
I doubt it, because I don't know. I really don't know, John. They've got to do something. They've got CyberOps Associate. I think this is a way for them to do a little bit lower level cert. Two of them, but it was so much better when we had CCNA security, CCNA wireless, we had CCNA data center. We had that kind of the mid-level certs. I think they're coming back. I really do. I believe they're coming back. I think they're going to have to. I think Cisco has seen that there's too big a jump from CCNA to CCNP Encore, but I mean that's just too big a jump. It's unbelievable. At the same time, they look at those numbers. They've got to see that they're, for regardless how whether we like it or not, certifications and certification testing is a money market, is a money maker for institutions, for companies. Their profit has had to drop in that area because they've had fewer people take certifications because there's no mid-level. From a simple business standpoint, I think it's going to make sense for them to bring something like that back. I have no inside knowledge on that whatsoever, but I just feel like if they don't, they're leaving a lot of money on the table, and they're leaving so many people in a career quandary, really, because they can't go. CCNA is one thing, and then the CCNP is so much higher. It makes no sense to have what's a entry-level cert or a little bit above entry level with CCNA, and then your next one is the same exam that prepares you or lets you take the CCIE.
Right, because right now they had two choices. They could do Checkpoint CCSA or a CCNA security, and since that's gone, the other ones there, and the cybersecurity, which they kind of separated network security from cybersecurity, they don't respect Cisco.
Yeah.
And all of their courses are these stupid incident reporting, ethical hacking, all of the courses that are fun and they don't really need a lab.
Right.
And to me, who's going to hire someone who can like write reports, but they can't set up a network? You know, that's my biggest concern. And
there are some positions on that, but usually those positions are people who've been in security for a long time and go into compliance. They're not our students coming out of 2 and 4-year degree programs typically.
Yeah,
they're people who've been in it and have moved into compliance. I agree with you on that.
Yeah, but you know, they're arguing that they have to meet the what is that called, CAE requirements, the Center of Academic Excellence from the NSA, to be able to do that. And they say, you know, Cisco doesn't cover enough of the bases to allow, you know, Cisco to count.
Well, that's hard to believe because most of the people I know who are CAEs use the Cisco class mappings to get their CAE. I mean, we just did it. We're using that as part of our mappings.
Well, maybe they're going soft in another area, but if you could send me information on that, because our Cisco program used to be like, you know, three campuses, 5 courses every semester, and now it's down to less than half. And
I don't get that because, like I said, that's just someone who's not done a lot of research, because I mean, if you look at the CAE, a lot of them are using the Cisco certifications.
I know. And the worst thing is that, you know, they're letting professors teach remote. And I'm thinking, how can you learn how to do anything with Packet Tracer? I mean, you do learn the commands, but you're not connecting things, you're not troubleshooting, you're not doing password recovery. You know, I'll get off that course.
Well, and anyway. I will say, one of my things is this: I really feel like, and we do teach it remote, but I agree with you. I think CCNA 1 needs to be taught in person, or at least hybrid, so they come in and do the hands-on. Once you move into 2 and 3, you could probably just do it all online and use NetLabs. Now, I wouldn't use just Packet Tracer because Packet Tracer is still a simulation. But I do agree. I think CCNA 1, you need that time with the equipment and playing with the equipment.
Yeah. Okay. And they haven't even let us set up NetLab yet. It's like we've had NetLab at 2 campuses and they never opened a port for us.
Oh, that's terrible.
Yeah. And if you're on campus, you might as well just go to the classroom.
Yeah, go to the lab.
Yeah. Okay, thank you.
No problem. Well, I also want to mention to everybody, we are in our last official week of class. So as of May 3rd, you will lose access to canvas.stanley.edu. You will not lose access to NetAcad. However, if you are ready, I just turned on the final written exam, and I turned on the final course feedback, and I turned on the practice final. Last but not least, as you know, inside of NetLabs itself, we have, excuse me, I'm eating a cookie and it's about choking. I have, inside of NetLabs, you have for your class, this ENSA SP, you've got this skills assessment. This is where you do your hands-on skills assessment right here. All right, and then you upload it into the upload area that I have for you at the bottom down here. So the skills assessment equipment, this is the one you need to do, and this is the one you need to upload for me. Okay, do not, I mean, you're welcome to do the PTSA if you want, but that's just for practice. It's not I'm not giving you credit for that one. I will actually enable it because I don't, it's enabled already. So I've already got it enabled. Access activation profile. Let's see if we can make it work. Yeah, it actually be on, and you can play with it if you want to, but the one I want you to do is the one in NetLabs, which is with real equipment. Okay, so to finish up class, if you haven't already done so, make sure you finish up all the module exams. Make sure you finish up any of the labs or packet tracers you need to finish, the hands-on final using NetLabs, and then your written exam, which I just turned on, and I did turn on the practice. So you got a practice written exam if you need to do, if you want to do that, which I strongly suggest you do. You might as well do it because it'll prepare you for that, the written. Any other questions? Okay. We only have 2 chapters left, folks, 2 modules, 13, 14. I'm really going to blow through 13 fairly quickly and 14 pretty quickly too. But we're going to talk a little bit about cloud computing and virtualization. I'm not going to spend a lot of time, but the world is going to virtualization and cloud services. It is definitely looking at different ways to move things into the cloud. There has also been, though, a little bit of a movement back on premises. I've been doing some reading, and I just got done with my AWS cloud fundamentals foundations class. I actually finished all the modules. I need to go take the exam fairly soon. But there's actually been some movement back into on-prem. People jumped on the cloud and didn't really do their due diligence and didn't realize how expensive it can be depending on how you use the services. These are ways to use the service, so software as a service. So great example there is my wife's business uses Office 365 and uses Exchange in the cloud. We used to have an on-premises Exchange server. I no longer have to worry about that. I've got it up in the cloud and I can manage it there. They're responsible for patching the Exchange server. They're responsible for ensuring the server stays up 365. They're responsible to making sure that there's a DDoS attack on it. So all of those things are taken care of by Microsoft and Office 365, which saves me a lot of work. The platform as a service, that's like development tools, programming tools, and then infrastructure as a service. This is where you're getting into things like the VPCs inside of AWS, so virtual private compute resources, the ability to run. I will say one of the things I've been very impressed with looking at the AWS. Have any of you done any of the AWS training? Any of you looked at it or messed with it at all? Yeah, okay. One of the things I was impressed with is looking at, so I got somebody in chat here. Okay, John has, okay, good. One of the things I was impressed with looking at is all the different, they do have so many different ways to provide you services. Everything from the full virtual VPC, so virtual network with your own, you spin up a box, you put Windows on it, you spin up a box, you put Linux on it, etc., all the way to a service like Lambda or a service like a Docker, where you can just have it literally just performing a set of calculations for you, or running just an application in a Docker container, and that's all it does. So it's interesting how they've got so many different offerings. That's also one of the pains when you try to take the exam, because you got to know all those offerings. But everything from running specialized database servers and different ways of doing database servers, that all expands or extends into this cloud infrastructure. Now, these are different types of clouds. So public clouds, so that'd be AWS, Azure, some of the Google Cloud stuff. And that's where it's a pay-as-you-go model. And, you know, one of the things that people really kind of get themselves in trouble is they don't do the calculations and don't think about how much they really need, and they'll either underestimate or they'll buy too much. I will say that is one of the things AWS seems to try to do, is provide you with a large number of tools that let you at least try to figure out the best services to use and the best way to provide those services for your network. Private clouds, that's what we do at Stanley Community College. I have an entire rack that is a virtual private, or it's a private cloud that is used by NDG. And one of the things that happens is, if any of your students go in to do a Linux Essentials lab, there's a good chance they're coming to a Docker container on one of my servers in the data center at Stanley Community College, because we were part of a grant with NDG. And as part of that grant, we created what was called the Academic Cloud. So when a student spins up one of those little Linux boxes inside the Linux Essentials class, they have an algorithm that goes out and looks and tries to find resources that are open to spin that Linux box up for the best performance and the cheapest cost. Now, if we're full, so if, let's say my server is completely overwhelmed, it may spin up in NDG's data center. It may spin up at the University of South Carolina's data center, or it could spin up in actually inside of the Amazon cloud. So there's ways to build what are called private clouds, and that's what we've done. The eventual goal would be down the road is to have multiple systems across the United States as part of this academic cloud, to where if a student wanted to run a VMware class, it could spin up at Stanley, it could spin up at USS South Carolina, it could spin up in AWS, all of those. And so that's kind of a neat thing. So that's what we've kind of done, is a private cloud / hybrid cloud model with that. Now, anybody run a data center? You know how expensive it is. And I've got a $25,000. Now, this is just to do maintenance on the batteries, the air conditioning units, and the generator that I have. It's $25,000 a year. That is 25 grand just to do those things. If nothing breaks, nothing goes wrong, that's replacing 0 equipment. It's $25,000 a year to do maintenance on my data center. Now that's a 7-row data center with 2 AC units and a full UPS and a 200 kilowatt generator. That's why people, when I don't just give away free NetLabs access, which I do try to do most of the time, but when I don't just give it away for free, I'm hoping they understand that's one of the reasons. I got to pay the bills. But that's the beauty of the cloud. Let somebody else build the data center for you. Let somebody else worry about the generators. Let somebody else worry about the power. Because really, the data center, yeah, the compute resources, the storage resources, all of that's expensive. But the most expensive thing in my data center that we bought when we put it in was the generator. So let somebody else do that. And we can use virtualization to make that happen. Here's the AWS console. Now, it does not look like this anymore. That's one of the negatives of the AWS console, is it changes almost weekly, it seems like. And so you just have to learn how to move your way around in it and find things. But it is neat that it is so powerful. We can actually virtualize servers. Now, we could have dedicated servers like we used to. And what normally happened with these is you'd have all these servers. They'd be a physical device with CPU, network memory, and they'd be running at about 30% utilization or 10% utilization. So we were wasting huge sums of money, especially when you think about something like a network management system and a Linux Radius server and a DHCP server. Having all those on different machines was a complete waste of money. Because it wouldn't, a DHCP server is not even going to strain a machine to do DHCP. So what we started doing was virtualization. And we got type 1, type 2 hypervisors. Here's an example of a type 1 hypervisor. And in this type, sure I'm right there. I always get confused about type 1, type 2. No, that's type 2. So we've got our servers. We're virtualizing type 2. You'll notice we end up with hardware down here. We put a hypervisor above the hardware, and then that hypervisor can split all of the hardware into virtualized resources to provide to our different servers. So instead of having all of these servers, 8 servers, we can do 2 servers and run our 8 servers as virtualized servers inside of our hypervisor, our type 2 hypervisor. Why is it better? Well, here's one thing: less power. That's a big one. There's less power. There's less AC to make these things run. There's less space in the data center, and there's better use of your resources. It's also easier to provision things, easier to do prototyping, easier to spin things up, spin them down. I will say the AWS labs are really neat because you get to spin up machines that you can actually connect to from the internet. So you'll spin up a little web server and hit it from the internet as part of your labs for the AWS classes. So we do teach those, by the way, if anybody wants to take them. We do the AWS Cloud Foundations and Practitioner, and we're getting ready to do the security class soon. So here we have, you're looking at different ways of doing the abstraction layers. So a type 2 hypervisor is software that creates and runs VMware instances. So I was right. Type 1 is bare metal. Type 2 is like VMware, virtual PC, those types of things. Virtual PC is not even around anymore. It's called Hyper-V. Used to be virtual PC, but it's not called that. It's called Hyper-V now. But type 2 is where you've got a piece of software running on the device, and then you run the OS inside of that. Type 1 is a full-featured hypervisor that is a bare metal hypervisor. So you take a box, you load ESXi on it, and then it provides services. So this up here is type 1. This down here is type 2. Okay. If you are not a member of the VMware education, or the it's now called something different. What do they call it now? I'm drawing a blank. But there's a new program now, but you can join it. The VMware Academy is what you need to join, because your students can actually get VMware Workstation for free. And then they can also get type 1 hypervisors for free use in the lab for their own lab use. Okay. How many of you worked with VMware or VirtualBox or Hyper-V? If you've done the lab for this class, you're actually going to play with Hyper-V.
We did that with all of them.
Yep. I've never used Fusions and I've never used Parallels. I'll admit I've never used either one of those two.
Well, I have Parallels on some Mac computer.
Okay. All right. Yeah, I've never used those two, but I mean they function very similar. If you can run VMware Workstation, you can run any of them pretty much. Or VirtualBox, if you can run VirtualBox in. The beauty of VirtualBox, it is free. And then here's our type 1 hypervisors. These are the bare metal hypervisors like ESXi. There is don't quote me on this, but I'm pretty sure there is a bare metal version of Hyper-V. I don't know Hyper-V very well. I have to admit that is somewhere I am very unknowledgeable. I need to get a lot more knowledge on that. I've not been involved in any Microsoft products in some time. But I know ESXi well, and I've used ESXi a great deal. So when you install this hypervisor's type 1 hypervisor, it sits between the hardware and any virtual machines you would load. And it is responsible for providing access to the hardware, basically slicing the hardware up so that those virtual OSs can have access. We teach a lot of VMware, so that's the one I'm most familiar with. This is an interesting thing here. Cisco has the Unified Computing Systems, and it has the ability to do all types of things with VMs and to actually integrate with different hypervisors. I worked a little bit with the UCSs. The one UCS we bought, I wasn't very impressed with. I'm gonna be quite honest with you. And that was years and years ago. But when they shipped it to us, it literally shipped to us in like 6 boxes, and we had to put the hard drives in, we had to put the memory in, I was not impressed. We use Dell servers right now. I mean, I hate to say that, but that's just what we do. I've heard the UCSs have come a long ways, and they're much better now, but I haven't worked with the UCS manager that much. Now, some of the issues in running virtualization is, I will tell you this, sometimes it's so easy to spin up a box, you'll spin up a bunch of stuff that you don't need. That's one thing I've seen. The other thing I've seen is you have to be careful about, okay, no problem. You have to be careful about east-west instead of north-south traffic. So north-south traffic is going in and out of your network. And that's the majority of where our traffic goes typically on our networks. However, inside the data center, a lot of our traffic is called east-west traffic. In other words, it's between our virtual machines. So one of the things when you go to design a network for a data center is you need to make sure that your east-west traffic has enough bandwidth. We do 100 gigabit ether channels between our switches, between our spine and our leafs in our network, so that inside of our data center, we've got basically 100 gig send, 100 gig receive, actually 200 gig send, 200 gig receive to each one of our leafs to ensure we've got enough traffic for east-west, or enough bandwidth for east-west traffic. Okay. So software-defined networking is now the big thing, and this is where we are taking and connecting to our devices with software interfaces. This can be RESTful APIs. This can be, today in my CCNP class, I'm going to use NetMiko to do some programming on a switch or on a router, excuse me. But you notice a network device has two things: a control plane, which is basically the brains of the device that handles forwarding decisions, layer 2, layer 3 route information, how you handle the ARP table, the spanning tree, how you handle switching or processing of packets, and then the data plane, which is your forwarding plane, which actually is used to forward traffic. We have the ability through software-defined networking to move the control plane away from the device itself into, this is an example here of a layer 3 switch with Ceph. So this, if you remember Ceph, it's Cisco Express Forwarding. You basically take the information in the routing table and you build all the possible forwarding information routes, basically all the possible ways packets could be moved. You pre-build them, load them into a table, and then instead of doing a lookup, you've got this fib and adjacency table so that when a packet lookup happens, it's extremely fast. It doesn't have to involve the CPU, doesn't have to do anything. And you know, the other one is called process switch, and there are other ways of doing it. With an SDN, what can actually happen though is instead of having it taking place on the control plane of the individual switch itself, we have the ability to have a centralized controller that interacts with each device. We even have, this day and age, white box switches that can be shipped that have no actual control plane in them, and then use SDN control planes to control the switches. Okay. Now, a couple things that can do for us: it can make it to where it's easier for us to control that traffic. It can make it where we can programmably handle the traffic. It also gives us better insight into the traffic because we've got a centralized controller that can see all the traffic. It also adds a lot of problems in there too for us, because now we've got another layer that we have to deal with. Here's that traditional architecture. You've got 3 devices, each with their own control plane. Whereas in the software-defined architecture, you've got a device that is your SDN controller, and all your data planes talk back to the SDN controller. And then the good news is, using APIs, instead of having to go and touch each individual device to make a change, we can touch the SDN controller, and that can be propagated out to all of our devices, which makes life much better in large environments. Now, we can get into all types of things like orchestration, SDN applications, the ability to look at a device and make sure it meets certain security policies, and all of those things. That is all part of software-defined networking. So again, here's a look at some open flow switches. So you've got an open flow switch, which, by the way, this is what a lot of the white box switches use. But using open flow, it uses that to talk to the SDN controller, and then using that is how it can talk back and forth. You'll notice the big thing here is with that centralized controller, you have the ability to have information about all the traffic on the devices in a single centralized controller. You also have what's called a flow table, which matches it to a particular flow. Typically, when we think of a flow, we think of the 5 tuples. So your source, destination IP address, source, destination protocol, and ports. Then you also can see a group table, and with that group table, you can trigger events. So certain traffic may have certain quality of services placed on them. Certain traffic may be blocked or allowed. So, and then even performance-related actions, rate limiting traffic. So you can look at the flow and say, well, if this flow exceeds a certain rate limit, we won't allow it to go to move past. And then Cisco's got all of these different things here. The ACI, or the application-centric infrastructure, which is their version of SDN. You'll notice using APIX, then there's application policy infrastructure controller there. It's got in the middle. That's their controller that these switches talk to. And then you can apply different profiles. This is what we have in our network, in our data center. It's what's called a spine leaf framework. And so you'll have a spine, typically super high speed, going out to leafs. And then you have controllers, and that APIC controller controls all the devices. Now they are looking at using Cisco Nexus 9000 series switches. We could not afford to put 9000 series switches in our data center. We ended up with Dell switches. We also only needed layer 2 functionality and layer 3 functionality. We didn't need a great deal of this SDN in our network. Be aware though, these things are expensive, very expensive. There are 3 different types of SDN. This device-based SDN is applications running on the device itself. There is a way on several of the higher end switches to run the SDN controller as part of a switch, and then that can go out to the data plane on other devices, or there's an application that runs inside of a little virtual machine on the switch itself, and it can connect to other devices. We have a controller-based SDN. This is where we've got some type of open or system controller like the APIC that sits in the middle. And then we got a policy, which is basically you have an application of this APIC EM talks to a policy, and then that can be pushed down into the SDN controller. The big thing about this, as you start looking at this, the more of these devices you add into your network, the more complexity it's going to add. There's no doubt that this adds huge amounts of complexity. You may have heard of the Cisco. I'm drawing an absolute blank. Their overall, this basically the APIC model is part of their overall smart networking infrastructure. But you'll see that it can see the entire topology of the network and understand the policy-based infrastructure that you set up, so that you can control traffic over your entire network and set all types of policies, procedures, all types of different quality of service using these software-defined networking tools. And here's this EM path trace, lets you see traffic flows, looking at duplicate or shadowed ACL entries. This is an attempt to get better understanding of how data is moving through your network. Now, the only thing is, again, this is complex. When you start putting in this DNA architecture, that's why I was looking for a DNA center, Cisco's DNA center. All of these pieces fit into that DNA center. It's a beautiful tool. It's a super expensive tool. And you also have to have, right now, there's been a lot of griping about it. I've heard it at Cisco Live for years about how Cisco's promised that this part of DNA Center is going to integrate with this tool and it's going to integrate with this. And then they'll say that for a couple of years and then they never actually integrate it. So Cisco has made a point in the past of leaving things unfinished, shall we say. Okay. Questions about that before we just jump over real quick to our last chapter on automation. Okay, we're going to blow through this automation pretty quickly. It's just basically looking at how we can do automation. Instead of us doing everything by hand, I will say this: if you've not been paying attention to AI, you might want to wake up. You know, obviously ChatGPT is blowing people's minds. There's, you know, ChatGPT 4 is doing, I think it recently it passed the bar in the 90th percentile. It's truly amazing. But as we continue on, I think we'll see more and more of automation with AI, which will make life easier for us. It's also scary because, quite honestly, you can tell an AI to do things now, like write a program to do XYZ, and it'll do it automatically. Here's our different data formats. Here's HTML. Everyone's familiar with it. The other ones that you probably want to know a little bit about is JSON, XML, and YAML, or YAML ain't markup language. You'll look, each one of these formats have specific rules about whether or not you're using semicolons, colons, brackets, squiggly brackets, That's what I call these squiggly brackets. But you'll see, here's an example of a JSON message. I would say know what these views look like. So here's JSON. Notice it uses squiggly and it uses keys. So item, key, key, item, key, item. So JSON uses the squiggly lines. You'll see YAML. This is the same information in YAML format, but it does not use any of the breakup that you see in JSON. And then XML is a little bit easy to tell because it looks like HTML. Okay, it uses a lot of the same formatting, slash notation, on, off, on with nothing, off with the slash. So JSON is human readable. You'll notice that with JSON, instead of putting this out like this, when you do a show interface gig 000, if you're running APIs and you do a JSON call, you can actually get it to output that same information like this. So name, the name of the interface, description, whatever description you put on it, and then enabled, true, that means it's up. And then you can see the IP address on it here. And if it had an IPv6, there'd be another section in here for IPv6. So for the exam, I would just know that JSON uses this format with the squiggly lines. It's a technical term. So object, each key value pair, you see a key, and then you get the value pair. So key and value. So notice hierarchical structure using braces. That's the real term for squiggly lines. And brackets hold arrays. Okay. Here's a JSON list of IP addresses. You'll see the braces and then the bracket holds the array. Right, there's the array inside of the brackets. Now YAML, there's JSON. Okay. YAML, you'll notice the format is very similar, but there's no braces. Doesn't use braces. Still uses key value pairs. Okay, but they're separated with a colon instead of using quotation marks or any of the other formatting you would see inside of JSON. And then last but not least, XML can take the same information and make it look like this. Okay. And they're called object tags. Each one of these has a tag on, tag off, basically is the way I like to call it. Slash tag, end tag. So begin tag, end tag. So name, the tag here is name, end name. Description, end description. Enabled, end enabled. So you need to know these formats: JSON, YAML, and XML. They could show up somewhere. And you've seen them 3 times in the chapter, which tells you where they're probably going to show up. Now, here's API calls. So the user can run an API call. That call can be made into any data format. It could be JSON, YAML, it could be XML. Using the correct APIs, RESTful APIs, or others, it can go across into the device or into the application and make a request and then get that information back in a standardized format that can be read. You also can push changes into a item or onto a device using this. And it's a good way to be able to do that without having to touch the devices. You can do it with an API call. So here's an example of an API call looking for airline website, trying to find departure city, date, return date, and it will go in and give you all those device items. All these are API calls to pull that from the database. There are different types of APIs. There are open APIs. Depending on the site, they used to have a lab from MapQuest. Obviously, MapQuest is pretty much gone now. But there are open APIs that you can pull for certain sites. There are internal private APIs that you can build for your own organization. And then there are partner APIs that you can use between business partners to facilitate business between 2 different devices or 2 different companies. So our different types of APIs, SOAP is one. SOAP uses XML. REST or RESTful APIs can use JSON, XML, YAML, and even others. And then there's XML RPC and JSON RPC. So those are using remote procedure calls. RESTful APIs are probably one of the biggest ones that are in use, because RESTful APIs use a similar set of information to an HTTP request, and so it's very similar to an HTML request or an HTTP request. RESTful implementation, you'll see here, you can use things like get for read. I would know this. Get means read. Post means create. So that's a create. Put update. Put patch is an update. And then delete is delete. So you can actually make changes to devices using RESTful APIs. Okay. As part of RESTful APIs, we have these UNRs, URIs, and URLs. Obviously, a uniform resource locator is the entire network location of a specific resource. The UNR identifies the namespace only. So that's just the namespace for it, not the full URL. And then you'll notice here, we've got a protocoler scheme, which is HTTPS, the host name, www.example.com, path is author/book, and the fragment is page 155. So that's what we're actually trying to call there. So the uniform resource indicator is this entire thing, whereas the URL would be just the portion without the fragment. And then the URN would just be the actual uniform resource name. So it's just the resource you're pulling a fragment out of. These are important when you make a request, because you may actually make a request. In this case, you're looking at the API server, looking at the resource you want, the format, the key, the parameters. So this is a RESTful API making a call to find out route to San Jose, California. Okay. And here's partial code from that. So we have all different types. We have developers websites, which would be the MapQuest website, Postman, an entire program that lets you do RESTful APIs and other API calls. It's a neat little thing you can use. Python, we can always do it with Python. So we can import the URL libs and requests, and we can actually write a Python script to do this. And then you can use netconf, or you can use a actual network operating system or netconf request to try to pull parameters. We have the ability in let me check this in one of the labs here. Go in here and find my. Well, all we're doing here is in this particular class, all we're doing is installing Linux in a virtual machine. I'm actually in just a little bit, I'm going to do this lab, which I'm going to use NetMiko to configure a router. So if you want to kind of see this, I'm actually going to do it in my CCNP class. So look for on my YouTube page, look for the class for CCNP today, and you'll be able to see me do that actual lab in class. Okay. So here's traditional network management. We go to the CLI and we do our work, or we go to a network management station and we do have some ability to at least see SNMP and those types of things. Today, however, we're going to the point of having a network automation. So we have a network management system to where we can push using RESTful APIs, using different types of programs. We can push and pull information off our networking devices using configuration management tools like Ansible, Puppet, Chef, SaltStack, all of those to access our devices. Now, you'll notice these are different ways of doing the same thing. All right. All of them support JSON and YAML. You'll notice that Ansible typically uses Python and YAML. Chef uses Ruby. Puppet uses Ruby. SaltStack uses Python. you'll notice here that with how our device is managed with Ansible, anything can be a controller. Whereas with Chef, Puppet, and SaltStack, there's a particular type of management device or management system. You'll see that Ansible is agentless, Chef is agent-based, Puppet and SaltStack support both. You don't have to have a huge understanding of these. These just good to know. These are some of the ways you can do configuration management. And then with intent-based networking, this is where things really start to get complicated. This is where you build out network intelligence so that when someone connects to the network using intent-based networking, it can actually put them in the correct place on the network. It can actually create what's called an overlay network to where, let's say someone connects and they don't meet the security policy, they can be shunted over to a remediation VLAN until they update all of their software. Once the software is updated, they then can be moved into the correct VLAN for their job role. That type of configuration relies on Cisco's DNA Center, and that intent-based networking, everything has to work correctly. Now, I'm not going to spend there's a lot of videos here, and I want you to watch those videos. But one of the things about DNA is it is a very complicated system that does a huge number of tasks for the network. But it's only going to be found in the biggest of the biggest organizations, simply because it's too expensive. It also doesn't make sense for small organizations. It's like I tell people all the time about dynamic routing protocols. Don't use a dynamic routing protocol if a static route will do the same thing. There's no need to. Use the static route because it's simpler, it uses less resources, and it'll save you time and money in the long run. DNA is the same thing. So you need to watch these videos and look at how the platform works and all the policy and provision and those types of things. But these are good videos, but I'm not going to sit here and ask you to watch them while I'm here with you. Okay. Now, folks, that's it. That's all of CCNA 3, Enterprise Networking Security Administration. Next week, May 3rd, is our last official day of class. I am not going to have class next week. We will not meet next week, so you will see me canceling that meeting for next week. I will hold a meeting the following week. I've got to go to the doctor next week on Monday, so I won't be here. I got to go to my the pain clinic. But we will meet the week after. So if you have any questions, if you get finished, okay, so if you get everything done, just email me and I'll go through and make sure everything's taken care of, and I will accredit you to make sure everything's taken care of. Okay. Are there any questions? Yeah, go ahead, John.
Yeah, can I ask you, when is the last time we can take all the exams and the labs and the
May 30th. May 30th.
30th.
Yeah,
Okay.
May 30th is drop dead date because I want to have everything done before we start our next round.
Okay, great. Because I've been so tied up the last 4 weeks with training new people and I guess graduation and all of these last of the semester things that I haven't been able to get past chapter 5. So I think I could catch up, hopefully.
Okay. Yep, that's no problem. And if we, worst case scenario, because this is 3, so you're not going to another class, we had to go past that, we could. I would prefer not to, but if we had to, we could.
Yeah, I don't want to keep you open. Let me ask you, are there any other free CCNA classes coming up or CCNP classes?
They're not going to be free right now because I don't have any grants. I'm trying to find more grants, John. If we get one, yes, I will. But unfortunately, our summer classes, we do have our summer schedule that's on our list.
Okay.
We have CCNA 1, 2, and 3, DevNet, CyberOps, and CCNP ENA RSI. So my hope is to do another CCNP Encore in the fall. And so, but right now they're not free. They're $195.50 because, again, I don't have any more grants at the moment.
Okay, that's the same price for all of the Cisco instructor courses?
Yep. Every one of our courses is $195.50.
Okay. The link to the your class schedule is on the website?
Yeah, I'll drop it in the chat. Give me 1 second.
Okay, because the people who took CCNA 1 and CCNP, I guess, and core, probably would want to take that next so they can, continue to, teach in the fall and at least have a semester worth of classes they can teach.
Well, and I wish I could continue to make them free. We gave away classes for free it ended up being a full year. So we actually figured it up. We gave away about $180,000 worth of classes. So, but that's the schedule there.
Okay.
All of our classes are, that, and the only way this is going to be true for the summer, no doubt. The only way for the fall it could go up a little bit is these are continuing education courses. State of North Carolina legislature sets all of our course costs. They could come and raise the price. If they do, it rarely raises by more than $5 to $10. And I've heard nothing about it being raised at all. So I don't expect it to go up, but.
Okay, but that's fine. We'll find money if we have to pay. But it's great that you're providing all of these free courses whenever you can.
Well, we definitely try. That's for sure. We try to. So.
Well,
All right. Anybody else have any questions? I'm gonna